Okay, I hope I'm audible to all students who are attending this lecture of statistical methods for economics. In this particular lecture, we intend to start with a few practice problems on probability. So we are going to solve a few numerical problems based on the concept of probability. Okay, which is one of the important modules in my statistical methods for economics course. Okay, so let's look at the questions one by one. Let me write the questions and then we are going to solve all these questions one by one. Okay, so let's look at the first question. Let me write the first question. What is the chance? What is the chance that a leap year, what is the chance that a leap year selected at random will contain 53 Sundays? So we need to find out what is the probability or the chance that a leap year is going to contain 53 Sundays. Okay, so let's solve this particular problem. Now, in a given leap year, how many days we have? So I can write number of days in a leap year. All students know that a leap year contains one more than the normal number of days in a non-leap year. So there are 365 days in a normal year. There are 365 days in a normal year, but a leap year contains one extra day. So there are 366 days in a leap year. Okay, now if I check this out in terms of number of weeks, how many total number of weeks do we have in a year? So if I divide 366 by 7, because a week contains 7 days. So 7, 5, 35 and 7, 2, 14. That means I can say that a leap year contains how many weeks? 52 weeks comprising of 7 days plus 2 extra days. This is my remainder. When we do the long division, this is my remainder. It contains 2 extra days. So I can say a leap year in terms of weeks. In terms of weeks, I can say that a leap year contains 52 weeks plus 2 days. Now 52 weeks correspond to 52 Sundays because every week contains one Sunday only. So 52 weeks are going to contain 52 Sundays. I need to check out what is the probability that a leap year is going to contain 53 Sundays. That means 52 Sundays will be for sure. Any year will contain 52 Sundays for sure. We are left with 2 days. Now, what are these 2 days? What are the possibilities we have? If I erase this part off, I'm erasing the question. I hope students have written down the question as well. Now we have 2 extra days with us. These 2 extra days can be Monday, Tuesday. They can be Tuesday, Wednesday. They can be Wednesday, Thursday. They have to be consecutive, by the way. They have to be Thursday, Friday, or they can be Friday, Saturday, or they can be Saturday, Sunday, or they can be Sunday, Monday. These 2 days can be combinations of these. Now, how many total number of combinations do we have? 1, 2, 3, 4, 5, 6, 7. So total number of possibilities is 7. For these 2 remainder days, total number of possibilities is 7. Favorable outcomes are how much, guys? I need a Sunday. A Sunday comes here and a Sunday also comes here. So there are two favorable outcomes. For the 53rd Sunday to come, there are two favorable outcomes. So my required probability, we all know how to calculate probability. It's nothing but the favorable outcomes divided by total number of outcomes. 2 by 7 is the answer for this question. Required probability is the favorable outcomes divided by total number of outcomes. I'm revising again. The question was asking us, what is the probability or the chance of having 53 Sundays? Any year will have 52 Sundays for sure. Why? Because if I talk about a leap year, the question gives me leap year. A leap year contains how many weeks? A week contains 7 days. The moment I divide 366 by 7, I get 52. That means it is going to have 52 weeks plus 2 extra days. These 52 weeks will contain 52 Sundays. I have 2 days left. These 2 days can be Monday, Tuesday, Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, Friday, Saturday, Saturday, Sunday, Sunday, Monday. Total possibilities are 7. For 53rd Sunday to occur, you have two outcomes which are favorable. Saturday, Sunday, Sunday, Monday. So my required probability for having 53 Sundays in a year is 2 by 7. So I hope all students have understood the solution to this particular problem and have no doubts. So let's now look at the second question. Question number 2. A bag contains 3 red, 6 white, and 7 blue balls. What is the probability? What is the probability that the two balls drawn, what is the probability that the two balls drawn are white and blue? Now, this is again a question based on permutations, combinations combined with the concept of probability. How many total number of balls we have? Very simple. We have solved these kind of problems in high school as well. If we had stats at the high school level, total number of balls are 3 red balls plus 6 white balls plus 7 blue balls, which are 16 balls in total. I need to select how many balls? 2 balls. In how many ways can I select 2 balls from 16 balls? I can write 2 balls can be selected from 16 balls. In how many ways? In 16 C2 ways. So I can write, therefore, my total number of outcomes is, what are the total possible number of outcomes? From 16 total balls, I need to select 2 balls. Now, we all know from the theoretical lectures on probability, how do we calculate 16 C2? 16 factorial over 2 factorial, 16 minus 2, 14 factorial. This is 16 times 15 times 14 factorial divided by 2 factorial is 2 only, times 14 factorial, 14 factorial, 14 factorial cancels out. 2 times 8 is 16 and 15 into 8 is 120. What are my favorable number of outcomes? Out of these 2 balls which I am selecting from 16 balls, 1 should be white and 1 should be blue. So how many white balls are there? There are 6 white balls. From 6 white balls, I must select 1 and. Remember, in probability, and means multiply. In probability, and always means multiply. Blue. 1 ball should be blue. How many blue balls are there in total? 7 blue balls are there. So from 7 blue balls, I should select 1 blue ball. So 1 ball out of 6 should be white. 1 ball out of 7 blue balls should be blue in color divided by total number of. So this is my favorable outcomes, basically. This is my favorable outcomes. So I can quickly write that my favorable outcomes are, how much is 6C1, guys? 6C1 is 6 factorial over 1 factorial, 6 minus 5. 6 minus 1 is 5 factorial. 7C1 is 7 factorial over 1 factorial, 7 minus 1, 6 factorial. 6 factorial by 5 factorial is 6. 7 factorial by 6 factorial is 7. 6 times 7 is 42. These are my favorable number of outcomes. These are my total number of outcomes. I can write my required probability. My required probability is equal to 42, which is my favorable, over 120, which is my total outcomes. Use your calculators and verify this is 7 by 2. The final answer for this question is 7 by 2. So I hope all students attending this lecture have understood how we have calculated the probability for this particular question. Okay, let's now move to the next question. So erasing all this off, let's look at question number 3. Okay, so let's look at question number 3. Let's look at question number 13. So two cards are drawn at random. Two cards are drawn at random from a well shuffled pack of 52 cards. Show that the chance of drawing two aces, show that the chance of drawing two aces is 1 over 221. Okay, so very simple. In a pack of 52 cards, students, how many aces do we have? All of us know we have 4 aces. How many non-aces are there? The remaining 48 are non-aces. What is the probability that both the cards are aces? The chance of drawing two aces. Probability that both the cards are aces. And this is happening without replacement. We are assuming that the cards are drawn without replacement. So what's the probability of the first card being an ace? Favorable outcomes 4. Total number of outcomes 52. And second card being an ace. Now out of 4, one ace is already gone. How many aces left? 3. Out of 52 cards, one card is already chosen. How many cards left? 51. So we have to just use logic. Very simple. We want both the cards to be aces. The probability of the first card being an ace is favorable outcomes 4 over total outcomes 52. Now that card is chosen and it's not getting replaced. It's happening without replacement. What's the probability of the second card being an ace? One ace is already picked up. How many aces left? 3 aces left. How many cards left? 51 cards left, because one card is already chosen at the first place. If you solve this, you can check out 4 times 13 is 51, 52. 3 times 17 is 51. 1 over 13 times 1 over 17 comes out as 1 over 221. This is the answer for this question. So I hope that students have understood this and have no doubts. Yeah. Let's now look at question number 4. So from a pack, so I can write, let me correct myself, 4 cards are drawn from a well shuffled pack of 52 cards. Find the probability that Find the probability that part A, all are diamonds. All are diamonds. Part B, there is one card of each suit. There is one card of each suit. Okay. And the third part asks us find the probability that there are 2 spades and 2 hearts. So again, it's a question based on cards. Okay. So let's quickly solve this question. Okay. Now let's look at the first part. We are drawing 4 cards from a well shuffled pack of 52 cards. What are the total number of outcomes? Total number of outcomes are, what are the number of ways in which we can choose 4 cards from 52 cards? 52C4. Okay. So these are my total number of cases. Okay. 52C4. Okay. Then I can now look at what is the probability of getting a diamond. Now, how many diamonds do we have? Out of 52 cards, we have 13 diamonds, if I am not wrong. 13 diamonds, 13 hearts, 13 clubs, and 13 spades. In a well shuffled pack of 52 cards, we have 13 diamonds, 13 hearts, 13 clubs, and 13 spades. So what is the probability that all are diamonds? So favorable number of outcomes are what? We want all 4 cards to be diamonds. So favorable outcomes are, out of 13 diamonds, I need to select all 4 diamonds. So 13C4. Favorable outcomes is 13C4. What is my required probability for case A? Required probability is, favorable outcomes are 13C4, because I want all my 4 cards to be diamonds. Out of 13 total diamonds, I need to select 4 diamonds, which can be done in 13C4 ways, divided by my total number of outcomes is 52C4. So favorable outcomes upon total number of outcomes. Okay, so I can leave my answer here also. 13C4 over 52C4. That is my answer for part A. Let's solve part B. So erasing this part off. Let's solve part B. Okay, so in part B, they ask us the following. So part A was all are diamonds. Part B is, there is one card of each suit. Again, the total number of outcomes will remain the same for part B. Total number of outcomes is, I need to select 4 cards from 52 cards. And I've just written that, guys, out of 52 cards, I'm revising again, 13 are diamonds, 13 are clubs, 13 are spades, and 13 are hearts. So now, what is my favorable number of outcomes for part B? My favorable outcomes are, there should be one card of each suit. That means one card out of 13 should be diamond, and means multiply. One card should be club out of 13 clubs, and one card should be spade out of 13 spades, and one card should be heart out of 13 hearts. So my favorable outcomes are 13C1 times 13C1 times 13C1 times 13C1. One card out of 13 should be diamonds. One card out of 13 should be club. One card out of 13 should be spade. One card out of 13 should be heart. Because you want one card of each suit. And there are 4 suits. Diamonds, clubs, spades, and hearts. So what is my required probability for part B? I can write that the required probability is, 13C1 times 13C1 times 13C1 times 13C1 whole divided by the total number of outcomes, which are 52C4. This gives me the required probability. And now part C, there are 2 spades and 2 hearts. Now I need 2 spades out of 13 spades and 2 hearts out of 13 hearts. My total number of outcomes are still the same. So if I erase this part off, and I now look at part C. So my total number of outcomes are still 52C4. What are my favorable outcomes for part C? My favorable outcomes are, I want 2 spades and 2 hearts. So out of 13 spades, I want 2 spades, and out of 13 hearts, I want 2 hearts. So my required probability for part C will be, the favorable outcomes 13C2 times 13C2 over total number of outcomes, which are 52C4. This is my answer for part C. Okay, so hoping students have understood this. I stop in this particular lecture. In the next lecture, we are going to continue with more practice problems on probability. So in the next practice lecture, we look at more practice problems, numerical problems on probability. So I stop in this lecture. I hope all students have enjoyed this lecture. Any doubts? You can unmute your mic and ask, or you can call up, or you can get in touch with me for doubts on mail at divineschoolofeconomics@gmail.com. This is where I stop in this lecture.